starts and then we can continue. Okay, great. So on Wednesday we basically stopped at this question. So I just want us to continue and finish study unit 6 today, and then I also just want to when we finish, just want to do one or two problems if we have time on the Excel spreadsheet as well, that you can see how to use Excel in this study unit as well. So let's start with nearly finishing off. Got about four questions left, and then I'll show you the Excel. Just remember again, important in this study unit part is definitely the definition part. So again, it might be something that comes up in the exam and most likely in your assignments as well. And then the second important thing is how to calculate the Z and then use the Z tables to get to your probabilities. Okay, so let's just quickly look at a definition kind of question. So in this one, they say the distribution that has a mean of 0 and a standard deviation of 1 is called what? Okay, so, and this is straight from nearly this slide. Let me just quickly see, is it that slide or this one? The standard normal variable is a normal distribution with mean equal to 0, standard deviation of 1. So straight from your definitions, it's not binomial, it's not Poisson, it's the standard normal distribution. Frequency distribution, definitely not, and the skewed distribution also not. It will be a normal distribution. Mean is 0, so mean is in the middle. We'll have, as always, the mean will divide the normal distribution into 2, that we set with 50% or 0.5 on the one side, 0.5 on the other side. So just remember, mean of 0, standard deviation of 1 is always a standard normal distribution. They like to ask this in assignments and in your exams and things like that as a definition question. Okay, so let's continue. So we still have a few that I think we need to calculate Z. Another one where they give you the Z values, and another one where they give you a few Z values that you need to work with. Question 13 again is nearly the preferred question for an exam type of question, because it tests nearly various options of a probability table, that if you understand it. Okay, but let's get quickly back to question 9. A psychologist has been studying eye fatigue using a particular measure, which she administers to students after they have worked for 1 hour on a computer. On the measure, she has found that the distribution follows a normal curve. Using a normal probability table, what is the probability of students having Z score below 1.5? Okay, so we know it's a normal distribution. Mean is 0. What is the probability of students having a Z-score below 1.5? Remember, to this side is positive, to this side is negative, so around 1.5. Let's just put that in, and below. Okay, so again, just following on what I tried to show last week or in the week, if this is 0.5, the purple area, then my answer that I'm going to look for will be bigger than 0.5. Okay, so now with even looking at the table and looking what we need, I can already say, well, it needs to be bigger than 0.5. So option 1 is not an option because that is much smaller than 0.5. That might be option 4 is not the option because that is smaller than 0.5, and that might be. Okay, so I have already eliminated 2 of the 5 options that was given to you just by looking at nearly the distribution or the graph that I have drawn. Okay, so we want this whole area. So 1.5. So I go down to 1.5. The one thing that we need to now realize here, it is 1.50. Okay, so going down to 1.5 and then across to where it's 0. So it's basically where these two meet. And that is then my answer, option 3. So just be very careful in this instance that what they are doing is, let me just quickly, what they are doing here is that they're not giving you the second decimal. The second decimal is at 0, so they don't need to show it. But just so that it doesn't make you confused when you're looking for it on the table, I add it normally so that I can know where to go across to. And then I get the number as 0.9332, and that is your bigger area, so it is option 3. Any questions thus far? Cool. Just stop when we need to look at something. Okay, so also what you and this will probably, not probably, it will be in your assignments, is that they sometimes now mix it up, the set of questions. So if an area to the right of a positive Z one is that. Okay, so I need to draw that because else I will not be able to do that. So they tell me it's a positive. So again, we know that's 0. They tell me it's a positive Z1. And then they tell me that if the area to the right, so to the right of that positive is 0.0869. Okay, so they're asking me that, or they're giving me that. Then they tell me, okay, but what is that value? Okay, so we know it needs to be a positive value. So this one is wrong. But when I look at that, I'm like, okay, why do they give me a negative and a positive number of the same? So by just looking at that, I would have probably in the exam guessed option 2, just because I'm like, why do you give me a negative? Um, but let's go through all of them. So what we could do is we could go to the table that we can see this value. So then we normally need to go to the negative table. Okay, so let's quickly see if I just do that for you. Okay, so let's get to, so I need to find the probability of a 0,0869. 0869, 0808080808. Okay, so the 0808. Okay, so there is my probability minus 1,36. So if it was on the negative side, it would have been minus 1,36. Okay, we're looking for the positive. We know from a definition that says this is symmetrical, so it should be on the other side exactly the same, but the positive of 1,36. Okay, so that's the one way we can do it. Go to the negative table, get the value, but then remember it needs to be positive. The other way we can do it is we can look at the positive value. So what we then need to do is to calculate this whole area, because then we can use the positive Z table. And how to do that is just by saying 1 minus 0,0869. The reason why we can do that is because we know from the definition that the total probability underneath a normal distribution is equal to 1. So if we know this portion is 0,0869, the other portion is 1 minus that. So if we then go to 1 minus 0,0869, we get the answer of 0,9131. Just be very careful, and this might now happen in the assignment, is that one of these answers might have been 0,9131. And that again is where, if you picked it, they will probably give you 1 mark. So again, I think there's a lot of questions about how you get 1 or 2 marks instead of a 0 or 4. So that might have been a way that they give you 1 mark instead of a 0. Okay, so now we have this probability. So now I need to go and look for the Z value that matches this probability. So I now need to find 0,9131. So 91 is there. Okay, then it becomes 92. I need to go to the other side. 9177, not yet. 6247, 9131. And if I cross check that, it gives me the 1,3 and across the 6. Okay, which gives me option 2 as the right option. Okay, so with this, you could have used two methods of getting to that Z value. You could have gone the route of checking, okay, it's symmetrical, so that small area I can get from a negative table, then I just need to make my Z value positive, or I can go the one minus to get the bigger area to still get to my Z value. And again, either or, which one works the best for you. I think the one that you're most comfortable with is the one that you need to work with. So if you're more comfortable in working with the positive Z table, and then work with it, please. Again, it is one that suits you the best. Okay, questions on that? Okay, so let's continue to the next one. Then I just want us to do a few. Okay, so this you will now see is yes or king.
Thank you. I don't understand because now when you check the area of the Z, it's 0.0869, and then it does correspond with negative 1.36. However, your answer is a positive 1.36. So if you can just clarify there, then I think I'll be fine.
Perfect. See, so they tell us in the question that we need to look for the positive Z. So they tell us that you must not look at the negative. You need to look at the positive. If they told us if an area to the left of a negative Z, then it would have been looking at that area. So it's basically we're following what they're asking. So they could have phrased this question to say nearly if the area to the left of a negative Z is 0.0869, what's the value of that Z? Then it would have been negative 1.36, because then it would have meant that left is to that side and we're looking at a negative value, so then it would have been negative 1.36. So it's all in nearly what they are asking us. So if I said left to negative, it would have been the minus 1.36, but they want the other side, that's basically the right to the positive. That's why we're looking at the positive value in the end. So it all depends basically on how they structure the question. So this could have been overking, like you said, it could have been just asked differently, then it would have focused nearly on the negative. So I think the most important part of and you see it now in your assignment as well is how they structure the question so that where you need to nearly focus on. Because this could have easily been written as in the area to the left of a negative. And then they will probably still give you the negative and the positive value. So be very careful also in your assignment when it's with different papers, because it could be that in the one assignment that you do, they give you the positive question, and in the next assignment that you do, they give you exactly the same detail, but they give you and ask you to work out the left and the negative. And then really you don't read the question, you just see the numbers and it's like, oh, but that was in assignment one and this is the answer. So just be very careful, because I've seen that now a lot in assignment 1 and 2, where they sometimes even give you the same data, but they ask the question differently, or they want the different answer to the question. But King, does that answer your question?
Yes.
Okay, cool. There was another hand, but I see it's gone. Was there another question? Simon, there's a question from you as well.
Yeah, manager.
Okay, so if we're giving the value of the positive side and then they ask us that we must get a negative, the left negative, we must also do it like this: 1 minus 0.931.
0.9. Quickly repeat that again.
Okay, if we are given the value of the positive side,
Yes.
because I think you were substituting this statement with negative, with the left
Yes.
negative,
Yes.
but given the value of the positive side.
Yes. Yeah,
So we must also minus it with 1.
Okay, so let's quickly, if, and this is recorded, so we can just quickly do that again, because I think that is important. So let's see, so let's do it this way again. There's the 0. They tell us it's positive, okay, and they tell us this is the 0.0869. Okay, so if I didn't go to the negative table at all, for me, the easiest would have been to use this table. So, because this is straightforward to calculate, and I know from the positive table, if I get this, I can go to where my Z will be. To calculate the purple, we say 1 minus. The 1 minus will give us the 0.9131, and that will give us the 1.36. If we needed, and this is an interesting one. So if we needed to, let's just want to take away. So let's say, and now I'm just going to change this to, let's quickly, let's keep that, let's still keep that to the right. Give an area to the right of I now want to see if I can change this to something else, but not really. So if an area to the, so let's make that the left. So if they ask us if the area to the left of a positive Z value, so sorry, it's now deleting everything. So if I set the area to the left, then we needed to say that area is 0.9131. So what they could have said, now that I've done this, is they could have used if the area to the right of a negative. Okay, so let's just read that one. If the area to the right of a negative, okay, so we know the negative is because there's 0. If the area to the right of a negative then what is the value of that set? Okay, so if I ask us, they tell us, well, this area is 0.9131. We need to find out what is that Z value. Then I would have gone again and said, okay, here's the small area that I need to find out. How to work that out, that small area, I would have said 1 minus 0.9131, which would have then given me 0.0869. Then I would have gone to the negative table to find that minus 1.36. So then again, it would have been very difficult nearly to see that that is exactly the same. But one could have again used symmetry. But for me, the easiest way always is to look at what I need to work out and then use the table that nearly looks at that. So if I need to find out that bigger area, I work with a positive table. If they give me this area, I need to work out that, I'll say 1 minus the big area in a positive table to get that. I will seldom go in the exam to the negative table first, just because one can easily make a mistake. So I would nearly say, okay, that area I need to find out, let's say 1 minus, or yeah. So again, to all the questions thus far, nearly find the way that it's easiest for you to deal with this, and which table is the easiest to help you in this. You have both tables. You just remember it is open book, so you can use all the tables that you have to your ability. You can write notes on those tables, like I think I've written here some notes on mine as so please use, as you go through some of these questions, use the tables, make notes on it. In the exam, you have that to your as access to it. What I would also do is remember the exam is very short. You're very pressured for time. So please use sticky notes to nearly get you to where the tables are and things like that. That you don't need to search for it in the exam. That it is nearly beforehand already marked that you can go to it. So remember, you guys are currently doing 12 or 13 questions per assignment. And your assignments at the moment is 3 hours for that 12 to 13 questions. In the exam, that the time frame comes down to like an hour and 15 minutes to do those 12 or 13 questions. So just be, as you also go through your assignments for the rest of the year, just see if you can do it quicker in a sense, or time yourself when you do it, that in the exam the time is very limited. So any notes, anything that you can get easy access to as reference will be really good to look at. Okay, so let's look at the last one. Here we will look at nearly, what is it, five ways to look at it. So I just want to nearly create let's just duplicate. So it is the same question, but I want to draw a lot on it so that we can just see everything. Okay. So the first one that they ask us is the probability of, and they ask us which one is incorrect. So unfortunately, sure, it's very difficult to. Okay, so let's first do it this way. If you look at 2.64, and that's why I nearly want all of them on one. Okay, so let's just take this out for now that I have enough. Okay, so Z bigger than 2.64. So remember that is the 0. So it might be that area is that small. So I can't ignore that yet. But when we look at the second one, Z smaller than, so we know that is 0, a negative 0.87. So that area is going to be smaller than 0.5. It is, I don't know yet if that is the wrong one. If I sit with the area, they ask us between 1.4 and negative 1.4. Okay, so I'm into two minds, but for me, this should be bigger than 0.5. It seems like it is. Probability that Z is smaller than, so minus 2.8, smaller than that. Okay, so we're looking at that area. So it needs to be smaller than 0.5. Okay, it is not. So that is definitely incorrect. And then they ask, is the probability of Z bigger than 0.74? Is that probability the same than the probability of Z smaller than 0.74? Okay, so this one is the first one that we can say is also correct. Okay, so that one was the incorrect one, and that one was what we were looking for. So without nearly working out anything yet, we could have eliminated, or we could have gotten the wrong answer. There was a hand, so quickly ask question. Yes.
Number 3, how did you make the assumption that it is, between it's 0.8? So
Okay.
the relation to 0.5, you just have to make sure.
Okay.
This one.
Cool. Perfect. Cool answer. So, cool question. So, how did I make the assumption? So, and that is more out of experience than anything else. I know that if you go up to around 1.4, 1.5, you sit here with around 0.4. So that is more out of experience than anything else. But if you look at, and you can also look at in your textbook where they give you, there's that one, and I have made a note on it for you guys on the PDF, where they talk about, let me quickly get it, the standard deviations. So mean with 1 standard deviation, mean with 2 standard deviations, mean with 3 standard deviations, where it is 68%, 95%, and 99%. So that nearly is giving me an indication that if I work with a number of, I think it's 1.64, I will just make 100% sure, but we'll get to that in study unit 7 as well, and study unit 8, where we work with confidence intervals. So this will be a very nice example of what we will do in confidence intervals as well. That you nearly get that idea of where it fits into. So for me, it is by pure doing this now for years and years, but you can look at that nearly, so that first page of my study unit 6 PDF, and where I had that graph, but we'll cover it later on as well. So this was purely out of experience that I got that. Okay. But also what I wanted to show you guys here is that sometimes one goes into such a state in the exam and in the assignments that you want to work out everything. And it might be that just by simply looking at some of the graphs, one can get the one that is wrong. I'll still make us look at all of them, but that for me is nearly, so I'll definitely look at this one to just see how we can get that. Okay, there was another question or hand somewhere, I think, or is it down again? Okay, so let me just go to this one and let's just look at it. So 1.4. So what we now need to, and I think this is also sometimes what makes that question difficult, is now we need to sit with, we're sitting now here with lots of info. If you look at the first table, the positive or the negative table will give us this value, the positive table will give us this whole value. So there's two ways you can do it. So, and I like to do it in colors. So I want this purple area. Okay, so that is the answer that I want, is the purple area. Okay, so from the positive table, and we'll get to that here, I will work out what is my answer from for this whole area to the left of 1.4. So there I see it is, so there I see it is 0.9192. To get to that purple area, I need to subtract the green area from the yellow, and then I will get the purple. So you can see purple plus green will give me the yellow. Okay, so purple plus green will give me the yellow. So I need to say, okay, what is my green area? That is where I go to the negative table of minus 1.4. Minus 1.4, 0.0808. So minus 0.0808, and that will give me the purple area. So 0.9192 minus 0.0808, and that will give me the purple area of 0.8384. Okay, this one is a tricky one because there's not really a shortcut. Another way was to say, well, it's symmetrical. So another way was to, let's just write it here, was to say, well, it's symmetrical, that we know. So that area is 0.0808. We've now seen that. So then this area will also be 0.0808. So we then could have said, well, to get this area in the middle is 1 minus 0.0808, which is this one, minus the other 0.0808, which will also give us the 0.8384. But see, again, it is, you need to do a lot of, so there isn't really a shortcut whenever we're working with two Z values that we need to get the probability between two Z values. There is really no shortcut. It is, you will need to work out the one Z, you will need to work out the other Z, and then most of the times you will need to subtract the two. And maybe on that question of how did I know that it will be bigger than 0.5, another one that they also like to ask is, what is the probability, and we're not going to work it out, but what's the probability that Z is smaller than 1,65, bigger than 1,2. Okay, so here we have the 0. There's a z of 1,65. And there's a z of 1.2. And I need to work out what's that probability. Okay, so again, if I need to work out something like that, I know that this whole area is 0,5, so that area will be smaller than 0.5. So that at least is again the one that I can check. Then again, here will not be anything easy how you will need to work out what's the probability of 1,65. So you will need to work out that probability, and then you will need to subtract the probability that you work out for the 1.2. And then you will be able to, because the one will be that probability, other one will be the yellow probability, which will give us in the end then the green probability. So I think there's just a few ways that they can ask this. They can do exactly the same in the negative space, but you basically can follow the same principle for that. Okay, so I just want to get one of these ones and see if, because I quickly want to see if I can show you on Excel. And hopefully this one works nicely, I hope. So again, in the Excel that I've shared, I'll share it again. It's not a problem. You will see that what I've done here is I've just put in, when we look at the normal distribution, the mean and the standard deviation. But please, here is the things that you can change. So they tell us here that we're looking at the X. So let's look at what they tell us. Long distance calls made by employees by a company normally distributed with mean of 6.3. Mean of 6.3. So as you will see, as I change that here, things have automatically started to change. Standard deviation of 22. Okay, there things have changed again. Use the normal standard table to calculate the probability that a call least 7 minutes. Okay, so remember we worked out the Z as 0,03. Here is your Z worked out as 0,03. Then what I've included is, if you basically would look at the Z or at that distribution, where we said, okay, so you will see now that there's the 0,15, so that's if it is smaller than the Z. So there's, sorry, bigger. So because we needed to work out that area. So there's the 0.5120. If we wanted the other area, it would have been that one. So again, and you can change the decimals every time according to what is in the paper as well. Okay, so here you can see how it was done. You can change it in this as well if you want to change this. So there's a few places in this depending on what you need to give nearly that you can work it out. I just want to set it to so that is the standard one. If you are, so like the one that I just did of the 1.4, if you're between two X values, you can use this one. Then it will give you the one in between. And if you need to find the Z score, if they tell us the probabilities to the left, there's also a calculation there for you to assist. So when you now go through some of the questions, use this in your prep. So when you do the assignment, that you nearly have this set up ready for you to use, so that you have that you have this Excel, that you nearly have this set of things with you as well, that you have your tables with you, so that it's nearly prep as if it would have been an exam, that you have all the things that you nearly can use and will use with you, and just see how it goes. Okay, so questions on study unit 6. Let's just go back to this one. So study unit 6 for me, as you now would have seen, very important, the definitions around it. Then the most important nearly is to calculate the Z and to get the probability when you have that Z. When we now go into chapter 7, the only difference that will come in is that we will start talking about a sample size. So here we've been working with populations. So the only difference in study unit 7 will be that we start talking about sample size, and that influence that the sample size will have will decide if we are looking at a normal distribution, and we use the Z, or if we are looking at a T distribution. But that is for next week. So for now, just make sure that you understand study unit 6, that you know nearly how to calculate the Z when they give you an X value, a mean, and a standard deviation. Okay, any questions, anyone? Okay, so I'll share the recording as quickly as possible. I'll make a PDF of this as the presentation as well, so that I can share the PDF to the WhatsApp group as well. When you have the Excel, the PDF, and the recording, so then study unit 6 is done, and we can start with study unit 7 next week. Okay, so I might create a longer session next week, but so that we can finish study unit 7, so that you guys can, I think the assignments open this week. I just want to get that we are nearly done with study unit 7 by next week. So it might be that even we have in the week a session again. I'll just look at load shedding schedules on this side, so that I just want study unit 7 nearly to be done by end of next week, so that you've got enough time to do the assignments. Okay, King, I think you wanted to ask something.
Oh, yes. On my previous question, the difference between normal distribution and normal density.
Yes, so on density, what is quite interesting is there isn't really a difference. It's just what you are looking at. So if I look at, so this is a normal distribution, normal density will just ask me how, in a sense, how dense it is in the wording. And that will also be referencing to the probability. So did you see it in the study guide, I think? In the textbook.
In the textbook.
Yes, so that's the first part of the textbook nearly, that is introduction to the normal distribution. So if you go into the maths of it, you will need to work out the normal density functions and those kind of things. So you guys don't need to worry about the maths behind it, how you need to get into the density function or anything like that. You can really take that as a given. So I know it's nearly that first part of that chapter. Read it as background. It's not for what's needed in this study unit. What they might do is use that wording in a question, because it's similar to what you guys are doing. So it might be like they've done in assignment 1, where they've confused me as well when they used the upper limit and the lower limit that was actually not referenced to Q1 and Q3, but there was somewhere in that chapter reference to that. So they might reference a question to say normal density function, but that is the normal distribution that you're working with. Happy with that, King?
Oh, yes, I'm happy with that.
Then also just be, I think it's in the same study, in that same chapter, we don't do exponential and we don't do the others. We only focus on the normal distribution. Previous years, all of those functions were dealt with. We only focus on the normal distribution. So we don't do exponential or any of the other weird functions that is in there. It's only the normal distribution.
So we're not going to deal with a uniform distribution?
No, not at all. Not at all. So not uniform, not exponential, only the normal distribution.
So even that formula calculating the Z, we're not going to use?
No. So only the Z for normal distribution.
Okay. Thank you.
Cool. Okay, so that is it for today, guys. Just check the WhatsApp. I'll definitely send all of these things through, but also check the WhatsApp for the next next session, because I will probably make it somewhere in the week that we can just, I want study unit 7 wrapped up by next week Saturday, so that it gives you enough time to still do assignment 3 with all the assistants. Okay, have a good weekend. Hope load shedding stays away. Yeah, and we'll see in the week. Cool, everyone. Have a nice one.